So welcome to Sotantra education. In this lecture we are going to discuss about the implementation of binary search tree in Java. So first we are going to create a class node. So we can write like this, class node, and it has three attributes. So for simplicity we are considering three attributes. So one is the integer value element, or we can say variable element of type int, and another one is a reference variable to the or a reference to the left subtree, another one is a reference to right subtree. So one reference is left, another reference is right. So left is referring to a node, and that's why we are writing the type of left as node and the type of right is node. So both left and right are referring to nodes of the binary search tree. So for that we are writing node left, node right. So for simplicity we are considering this int element, otherwise you can use the concept of generics or any character or string, anything you want to write here you can write. Okay. So now we are going to initialize these values. We can use a constructor for this. So let the constructor is like this. We can write node and int element, we are taking one parameter, and we can initialize like this dot element equal to element, this dot left equal to null, this dot right equal to null, then end of constructor, end of class node. So these dot left equal to null, this dot right equal to null. So these two statements are optional. So if you want to write you can write, otherwise if you want to omit you can omit, because if you do not write these two statements, so by default left and right will be null. So the default value of left and right will be null if you do not initialize explicitly, because by default reference variables are null in a class. That's why if you want to write this one you can write, otherwise if you want to omit you can omit. Okay. So now we will write another class where we are going to define all the methods that we have discussed earlier. So we can write a class BST. So in the class BST we are going to define the operations of binary search tree that we have already discussed. So BST here for binary search tree. So in the class BST we are going to define a root node, and initially the value of root is null. So for that we can write node root equal to null. Now we are going to write the add BST method, or insert one node into the binary search tree. So we can write the method like this, public, and the return type is node. That means after inserting a node the method is going to return the root. So that's why we are writing here the return type as node. So public node, then the name of the method is add BST, and it is taking two parameters, one is root, another one is the new node, or we can say or the value of the element present in the new node. So for that we are writing node root, that means we are taking root whose type is node, and another one is the key whose type is int. Okay, so we have already discussed about the add bst method earlier, so you can see the algorithm. So here we can see the algorithm we have already discussed. If the tree is empty, root to the new node, set root to the new node, return new node. Otherwise, if new node less than root, then return add bst left subtree new node, else return add bst right subtree new node. So these things we want to write. Okay, so if the root is null, that means the tree is not created, so we can write like this: if root is equal to null, that means the tree is not there. So for that we need to create a new node and assign its reference to root. So how to create new node? So we can write the new node like this: new node, for creating the new node, and pass the value of the key as argument. So in this way, using new node key, we can create a new node whose element value is key. Now assign its reference to root. So for that we can write root equal to new node and key, and after this return root, because the return type of this add bst method is node here. So we are creating the node and returning this. So we can write a curly braces for this. So if root equal to null, that means initially the tree is not created. So create a new node, assign its reference to root, and return the value of root. So now assume the tree is there, and we are going to compare the key value with the tree. So if the key is less than the root node, then we are going to add that new node in the left subtree, and if the key value is greater than the root, then we are going to add that in the right subtree. So that thing we are going to write. So we can write like this: if key less than root dot element, because here we are considering each node have one element that contains the integer value, and based on this element we are finding the order of the binary search tree. Okay, so if key less than root dot element, so we can write, or we can recursively call this add bst method like this. So add bst and pass root dot left and the key value as argument. So here we are going to pass root dot left as the new root, because here in this left subtree we are going to add the key. So that's why we are writing root dot left. So this method add bst root dot left key, so this method add bst method is going to return one node. So assign its reference to the root's left subtree. So update this one, update the root's left subtree. So for that we can write root dot left equal to add bst, then root dot left key. Now else, in the else part we are going to write, that means when key greater than root dot element. So here we can write the same thing, root dot write equal to add bst root dot write key. So here we are recursively calling the add bst method on the left subtree or on the right subtree, and we are updating the left subtree and right subtree. Then at the end we can write return root. So this is all about the add bst method. So we have already discussed the algorithm earlier. This is the implementation of add bst or insertion of a node in the binary search tree. Now we are going to define another method, that is search bst. That means whether one element is present or whether one node is present in the list or not. So we can see the algorithm for search bst we have already discussed. So here you can see. So if the tree is empty, return null, that means the element is not found. And if the target key is less than root, then recursively call the target key on the left subtree, and if the target key is greater than the root, recursively call the target key on the right subtree. Else, that means this target key less than root, target key greater than root, condition fails, that means target key equal to root, then return the value of root, or we can say found the target key. So the same thing we are going to implement. So here we can write like this. So the method public, then the return type is boolean, that means it is going to return true or false. If the element is present, it is going to return true, otherwise it is going to return false. And the name of the method is search bst. Okay. So now it is going to take two parameters. One is the root and its type is node. Another one is the key value and its type is int. So we can write like this: node root int key, and give the curly braces here. Okay. Now if root is null, so if root is null, so simply we can say return false. So if root is referring to null value, then the tree is not existing, so we can say the element is not present. Now if the key value is less than root dot element, then we are going to search in the left subtree. So we can write like this: return the same method we are calling search bst, then root dot left we are passing and the same key value. So this s is small, so this method name always starts with small letters, so don't get confused. Okay, so now we are going to check another condition. Else if key is greater than root dot element, then we can return the search bst method. We can call the search bst method recursively on the right subtree. So root dot right, then key. Now else means, so this one is false, this one is false, this one is false, this one is false. That means key value is equal to the root value. So we can say return true, we can write. That means the element is found. So this is all about the search bst method. Okay, so we can end curly braces to represent the end of the method. So this is all about the search bst method. So now we are going to discuss another method, that is find min, or to find the minimum node in this or in a binary search tree. So we have discussed the algorithm, that is always move towards the extreme left to find the minimum node or to find the node that contains minimum element. So for that we can write like this: public, and the return type is node, and the name of the method is find min. Assume name of the method is find min, and it is taking the argument or parameter node root. Okay, so now we can write here if root equal to null, then return null, Now else if root dot left equal to null, that means no left subtree exists, then we are going to return the root. So if no left subtree exists for a node, then that is the minimum value. So that's why we are writing return root. Else return, so if the left subtree exists, so call the find min method recursively on the left subtree. So else we can write return the same method find min, then root dot left. So end of the method. So this is the find min method. So now we are going to discuss the find max method. So it is similar to the find min. So just write right in place of left, because here we are going to move towards the right. So we can write like this: public node find max, then node root, then the same thing we are going to write if root equal to null, then return null. Else if root dot right equal to null, return root. return root, else return find max root dot right. The same thing we are writing. This is find min, this is find max. So if root dot right is null, that means no right child exists, then that node is the maximum node. Otherwise, call the find max method on the right subtree. So now we will discuss another method, that is delete a node from a binary search tree. So how to delete? So we have already discussed about the algorithm delete BST like this. Delete BST if empty tree return false, if delete key less than root, then call the method on the left subtree, else call the method on right subtree. Now if the node that we want to delete has only one child, then these are the steps, and if the node that we want to delete has two child, then these are the steps. So we have already discussed these things. So we are going to implement the algorithm like this. So we can write the method. So public node, assume the name of the method is delete BST, and it is taking two parameters, one is root and the type of the root is node. So we can write node root, and another one is the key value that we want to delete from the binary search tree, and the key value is of type int. Okay, so now we can write first if root equal to null, then we can write return null. Now again we can check if key less than root dot element, then we are going to recursively call the delete BST method on the left subtree and update the left subtree like this. So we can write root dot left equal to delete BST, then root dot left and key. Now if key greater than root dot element, so for that we can write else if key greater than root dot element. So simply we can write root dot right equal to delete BST root dot right and key. So if the key value greater than the root dot element, then we are going to recursively call the delete BST method on the right subtree and updating the right subtree like this. So this is the statement for. Now if the node has only one children, so if we want to delete a node that has one child, so for that we can write, or we can check else if root dot left equal to null. That means no left child is there, only right child is there. So we can simply return the right child like we have discussed in the algorithm. So return root dot right. Now if the right child is null, so we can write like this: if root dot right equal to null, return root dot left, like this. Now if the node we want to delete that has two children, so for that we can write else root dot element equal to find mean root dot right dot element. That means if the root has both the children, we want to find the minimum from the right subtree, and that value, that minimum value from the right subtree is copied to the root value. So that thing we are writing root dot element equal to find mean root dot right dot element. That means we are finding the minimum value from the right subtree, then that minimum values element is copied to the root dot element. Now we are going to delete this minimum value that we find from the right subtree. So for that we can write root dot right equal to delete bst root dot right comma root dot element, because root dot element contains the minimum value from the right subtree. So we are just calling recursively the delete bst method, and we are passing root dot right and root dot element, and we are updating the root dot right, or we are updating the right subtree in this way by calling the delete method recursively. So this is end of else. Now we can return the root value. So this is end of method delete bst. Now we can write another method to print the in-order traversal of the nodes. So for that we can write the method in order. So let me write the method like this. So public void in order, and we are taking the root as parameter, and here if root not equal to null, so first we are going to visit the left subtree. So we can call the method like this. So in order in order, then root dot left, then we are going to write system dot out dot print root dot element. So in short I am writing system dot out dot print. So in short I am writing s dot o. So system dot out dot print root dot element, then some space we can write, so plus some space. Then after printing the root dot element, again visit the right subtree recursively. So we can write in order, then root dot right. So end of this if, end of this method. Now end of this class BST. So now we are going to, so this is for end of class BST, this is end of method in order, and this one is end of if statement were written here, if. Okay. So now we are going to write another class, that is we can give the name test to write the main method. So we can write like this, another class we can write class test, then we can write public static void main, then write the string array args, then we can create an object of class BST. So we can write like this. So inside main method we can write BST, suppose my BST equal to new BST, then we can write, or we can call the add BST method, delete BST method, all the things on the object my BST. So we can write like this, my BST dot add BST, and it is going to take add BST is going to take two arguments. So one is the root, another one is the key value. So you can write like my BST dot root, and the value is suppose 50. So this add BST is going to return an object of type node. So we can store that in my BST dot root. So my BST dot root equal to my BST dot add BST, then it is taking two arguments my BST dot root and 50. Similarly we can add some other values like this. We can write my BST dot root equal to my BST dot add BST. Add BST is the name of the method, and here my BST dot root, and assume the value is suppose 30. Similarly we can add some values like this. Same thing, we can just here update 20. Similarly we can write 40 like this. Similarly we can add some. So after that we can print, or we can call the inorder method that we have just defined. So we can call like this mybst dot inorder. So it is going to print the inorder traversal of the tree that we are passing the root as the argument. So we are passing mybst dot root as the argument. So it is going to print the inorder traversal of the binary search tree mybst. Now we can call the find max method like this. So it is going to return a node. So like this we can write node max equal to find max mybst dot root. Now we can print system dot out dot println max dot element. So max dot element will be the maximum value among the nodes present in the tree mybst. Similarly, you can take another node mean and we can call the find mean method. So find mean, and same we are providing mybst dot root. So here we can print system dot out dot println mean dot element. Now we can delete one node and update the root like this. So we can write mybst dot root equal to mybst dot delete bst. So we are calling the delete bst on mybst tree. So delete bst and pass the root node of mybst. So mybst dot root, and assume that we want to delete 50. So we can write like this mybst dot root equal to mybst dot delete bst mybst dot root and 50. Now we can again print the inorder traversal like this. So mybst dot inorder, and here we can see mybst dot root. So if we call the inorder traversal here, so you can see the 50 will be not there. So here in the inorder traversal 50 will be there like this. So now this end of the main method, end of the class test. So this is all about the implementation of binary search tree in Java. So now we are going to write these things in a machine and see how it works.